All right, so for this next section, we're going to go ahead and do some more trig. Part 2 is what I like to call it. You guys had a warm up that you were doing. Now, we looked yesterday when we were given basically or asked to find a side length given an angle. Now we're going to go ahead and figure out how to find the missing angle. There is no new, vocab for today. We are going to use inverses, but I'm still going to be using my same acronym. You guys should hopefully have this memorized before you leave your geometry class, okay? SOHCAHTOA. We're going to start by doing this problem the exact same way that I showed you in the last section. I'm going to look at what's given. In this case, they give me this Greek letter, which is called theta, okay? And I'm also going to, in comparison to that angle, figure out what these two sides are to that angle. So since my angle is here, 13 is all the way across on the opposite side. So 13 is opposite. 34 is definitely not my hypotenuse, and it is touching the angle that I'm talking about. Right next to it, it's adjacent to it. So now I'm going to look at my trig functions, and I'm going to ask myself, which trig function has an O and an A? We're just pulling the first letter from each of those words. So which one uses O and A? Looks like tangent, right? So tangent, in this case of theta, is going to be opposite over adjacent. So let me just plug in. Tangent of theta is going to be 13 over 34. Okay, so what I'm asked to find here basically is what is the measurement of theta? And theta is a degree. So when you are trying to find an angle measure, you're going to use the inverse. So in order to find theta, I'm going to use the tangent button, but it's not just going to be a regular tangent button, it's going to be the tangent inverse button on my calculator. So I take the measurements and I just am going to do tangent inverse of that. Make sure it's tangent inverse and not just tangent. So you'll get completely different answers. Let me go ahead and show you how to do that on our calculator. So tangent inverse of 13 over 34. Tangent inverse of 13 over 34. So I'm going to pull up my calculator here. And again, my question was tangent inverse of 13 over 34. Always verify that you're in angles. By the way, if it looks like it's getting a little bit too crowded here and you like everything neat, you can always hit shift and clear and it'll get rid of the whole screen for you. All right. Now, in order to access the tangent inverse, you guys see how all of these letters here, see the sine, cosine, and tangent button? And in blue, there's an A sine, an A cosine, and A tangent. Well, that A stands for arctangent, which is the exact same thing as tangent inverse. So when you're trying to take the tangent inverse of a function, you never just want to hit this tangent button. See how it doesn't have the -1 there? And it doesn't have the A. So that would give me an incorrect answer. What I need to do in order to access the blue part of this button is hit the shift and then the tangent. And now you'll see the A in front. And again, the A tangent stands for arctangent, which is exactly the same as tangent inverse. So I said we're going to do tangent inverse of 13 over 34. I hit enter and I'm going to pretend like my question was saying round to the nearest 10th like it did before. So if I rounded this one to the nearest 10th, my solution would be 20.9 degrees. Now for this particular question, I would need to put the degrees or Celsius symbol on my solution because my answer is an angle. It's not a side length, right? It's not a measurement of one of the legs. So please make sure when you're answering angle measurements that you include the Celsius symbol or the little degree symbol. All right, let's go ahead and see what we have next for this one. Okay, let's try another one. So for this one, again, I'm going to start with my same acronym. So, TOA. I'm given this angle, and I want to ask myself, what are these two legs in comparison to this angle? Well, I know that this one is my hypotenuse because the hypotenuse is always across from the 90 degrees. And the 25 is going to be my adjacent because it's directly touching my angle and it's right next to the angle here. So now I look at SOHCAHTOA and I need the acronym that uses an A and an H. So I'm looking and I notice that cosine of theta uses adjacent over hypotenuse. Always remember that the first letter that you have there is always your numerator and the last letter is the denominator. So to find cosine theta, I'm going to go ahead and plug in. My adjacent in this case is 25 and my hypotenuse is 32. And the new part for the rest of these questions is to go ahead and use your calculator to find this. And we're going to be using the arc cosine, which is the same as cosine inverse button of 25 over 32. I'm going to show you one more time how to do this with your calculator, and then maybe you could just check your answers from now on. So 25 over 32 cosine inverse. Here we go. So again, in order to access the cosine inverse is the same as arc cosine. So I need to hit the shift button, and that activates the blue part of that button. And then I believe I said 25 over 32. I'm going to go ahead and hit enter. And again, let's pretend like this question was asking for the solution to the nearest tenth. My answer would be 38.6 degrees, making sure that I put my Celsius on my solution because this is an angle that I'm asked to find. So 38.6 degrees is the solution for this one. All right. That should be enough practice for you guys. You have quite a bit. There are some questions on your homework that I didn't go over, but they're just calculator questions. So it's just practicing typing in. If you see the little -1, that means make sure you use that blue shift button. And if you don't see it, then, or if you're asked to find sine of x, you're still using the shift button, right? But if you don't see it any other time, then you're just going to plug straight in. So just be careful when you're looking at those questions, and I'll make sure to review a few of those problems tomorrow when we have our Zoom session. Have a great day.